La la la, lost in lambdas, la la la, lost in lambda. Hey friends. So nobody really likes those super long intros, so what do you say we dive right in? Quote a friend of mine. What the fuck even is state management anyway? This much I know. Clojure devs, y'all hate it. But you don't have to hate it. So who am I talking to in this video? Talking to Clojure developers that are banging their way through a reactive Clojure script application. Some flavors of this are Reframe and Reagent. They're really just wrappers on JavaScript's React, though.
Necessary disclaimer. I'm only doing a small glossy overview of reactive state. I'm going to be going over reagent because that is the thing that people tend to have the most questions about. I encourage you to look at the documentation and talk to your team about whatever flavor of reactive application you are doing. This is not intended to be a full-bodied course.
Okay, back to the good stuff. What will I be covering in this video? Today we're going to talk about atoms. Hopefully that'll be a review for you, plain old atoms. But really we're going to focus on the difference between plain old atoms and Reagent's reactive atoms. They operate a bit differently, and knowing the difference is going to be necessary to render your view. We're also going to talk about another flavor of reactive atom, which is component local reactive atoms. These are appropriate in certain cases, and some of this has to do with stylistic choices. The last thing we're going to go over today is reagents are atoms make reaction. This is very important for you to understand how state changes through an application and how we can set things up to have a nice flow based on user input. So in another video that I hope to release soon, I haven't started yet, but we'll see, we will be going over the reframe stuff. So reframe is just a wrapper on reagent. Today we're going to be talking about reagent, the underlying mechanisms that reframe wraps. So to get started, hopefully this is a review. Plain old atoms. Plain old atoms are just a nice little sandbox for immutable state in Clojure applications. Typically, you will see them declared in a namespace. You can use functions such as reset and swap to change the inside of the atom. And swap is used more commonly. A very common pattern is swap, the name of the atom, and then the function you pass into swap as update. That's just a very common pattern. I'll be using that shortly. You can check the value of the state that you put in the atom by dereffing it. Most people just use the syntactic sugar, which is the @ sign. And that's really just checking to see what's going on in that atom. So what I'm really excited to speak with you about today is reagent atoms. We call this using r\atom. And this is how you deal with immutable state in a Clojure script application. It works exactly the same. You can use reset, swap, you deref it using the @ sign. But the special thing is that it tracks any deref made to it. And that when the state is updated, it causes the component to re-render. So when you put this bad banana in the body of a component, when the state of the R atom changes, it causes the component to re-render, which is what we need if we want to see a properly updated view. Cool! Another nice feature they have are cursors. So it is not uncommon to keep a bunch of state in one big atom. We're looking at you, AppDB. Cursors allow you to get some fine-tuned control into the larger atom or into multiple parts of the larger atom. The advantage to this is so every single component in your application doesn't re-render every single time a small piece of data changes. It's better for performance, and it's just a more elegant design technique overall. Okay, so we have a code example here that I'm going to demonstrate the difference between a plain old atom and a reactive atom. So here on the left, we have the web page that the closure script is rendering, and it holds 3 counters. On the right here is the code that is rendering the web page. We have our rainbow header, a couple of atoms, and a counter. This is the counter I was just speaking about. This is the same namespace, and this bottom is the view of the bottom of the namespace that's rendering the application. So starting here, we take our counter, which is a simple counter. It takes an atom as an argument. Whether that's a plain old atom or a reactive atom is up to us. So it takes that and it updates the state of the atom based on user input. A button, in this case, it's a button press, plus or minus, and it displays the result. Okay, so we have the plain old atom is this, and we can deref it and see that nothing's in there. We have the reactive atom. So let's go and interact with this a little bit. Okay, here I'm going to try to increase the counter of the plain old atom. I've clicked this a few times, but the number isn't updating. Well, let's deref this. Let's check. Well, it says that the counter is 5. Huh, I wonder why 5 isn't showing. Just kidding, I know. That is what happens when you try to pass a plain old atom into a component that needs to render new state. So, alternatively, in the reactive atom, which you can see is the second one here, we're taking the counter and we're passing in we're passing in the state as a reactive atom. So this our atom right here. All right, let's interact with this. Oh, cool. It works out just as expected. We can go up, we can go down, we go back to our REPL, we can deref it. And we can see that it is consistent. So let's see that again. We try to change the state of the plain old atom, and the view doesn't update. The atom updates, and we can check that by derefing. So if we want our application to show the changes in state that we're making, we want it to re-render, we need to use a reactive atom. All right, get it? Got it? Good. So another flavor of managing reactive state are using component local reactive atoms. So there's a school of thought that says that you should really keep your components on a need to know basis. This school of thought has reactive atoms declared in the let of a component and then wrapping the body in an anonymous function. So when that let changes, it will rerun the body of the function. This is valuable in very particular cases, and this is also known as a form 2 component. Okay, let's dive into the code again and I can show you what I mean. Okay, the last counter we have here is the component local atom. So this is another way to change state, and there are particular circumstances where you want to use this. We have counter 2 where we're declaring the state within the component, and we are still using a reactive atom here. We do a let, and then we wrap that. We put a function right after that, and this function is what it's re-rendering. when we swap that local state. So let's see how this works. You see, just like the above reactive atom, this also re-renders. Now, there are different schools of thought on when to use each. Personally, if I'm making some local state and it's just a reactive application and if you're only using it in the component, then I would declare it locally and use component local atom. Personally, I don't use a lot of namespaced atoms. There are people that do. Again, this comes down to personal preference. I'm sure somebody can find some best practices somewhere. I'm just here to tell y'all what I know. Okay, something else that is important to note, a way that you can screw this up is parentheses mean things. And in this case, we're using components, so we want to use the hard brackets. Let's take a look at what happens if I call a component, and just we'll go up to the component here. So this is the component, and let's see what happens when we call it using parentheses. All right, I'm going to save here. Oh, you get a warning. Functions are not valid as a React child. This may happen if you turn a component instead of a component from render. Or maybe you meant to call this function rather than return it. Either way, you screwed up. So just something to note when we are working in Reactive, when we're working in ClojureScript and we're rendering views, you're pretty much always using these hard boys. Now let's take a look at if you don't use a form2 component and you declare reactive atom in the let. So let's get this out of here. We will save it. So now when I try to change the state of the component local atom, since the body, the state is changing, but the body isn't re-rendering. So let's use a little trick that I like. I call this the deafen test. So we will do this, and now we can check the value of that reactive atom here. So let's do that. And you see the state is not updating. Sad. So this is another way that you can screw this up. Something else to note is that component local atoms are a little bit more delicate than namespace reactive atoms. So as you are developing, let's say let's change this back to a form2 here, as it should be. All right, let's save, and you can see that that state got cleared. So when you're developing, that's just something to be aware of, that component local atom state is a little bit more delicate, which makes sense that whenever the component re-renders, that state will get wiped. All right, on to my favorite part of this video. So we're going to talk about reagents make reaction. So you will find it in the reagent.ratom namespace. You're going to want to import it and typically refer it in. So make reaction is most similar to watch. It watches for changes, and if changes take place, it just runs a function. So reactions, in my opinion, are one of the most important parts of a reactive application because a web page is basically just like a bowl of spaghetti, user input spaghetti. And if changes aren't a catalyst for an update in behavior or a side effect, then all this mutable state just goes to waste and is useless. So, make reaction takes a function, and when the state changes, it runs that function. This may sound familiar to some of y'all who have used reframe in the past. Sort of like a subscription, don't you think? Let's dive back into the code and take a look. Last code example here, we are going to dive into make reaction with a contrived example. So in this contrived example, you are helping out a buddy of yours who owns a local restaurant. It is a coffee shop and he is having a hard time hiring a general manager. Part of the responsibilities of a general manager is typically monitoring the inventory. He has asked you to create a plugin to his POS system, which stands for point of sale system. This is an actual term. and something to plug into his point of sale system and help his associates be able to order more inventory when some items get low. So first thing we do is I set a reactive atom with a hash map. He has 10 fruitcakes, none of which will ever sell because it is fruitcake, 8 coffees, and 10 buns left. Here we have the make reaction, and the function that we are passing into it simply gets the count of the buns. Here we have a side effect function called item purchased, and this is to simulate a purchase happening in the point of sale system. So it just takes an item as a keyword and it updates the inventory up here. We have another side effect function, and this is called order more. And this uses an API from a food distributor to order more buns. We picked an arbitrary number, 20 more buns. Ideally, in a perfect world, when the callback is received that the purchase went through successfully, that's when we would actually update the application state. But for these simplified purposes, we don't need to get callbacks involved. So as an example, we're using restaurantdepot.com and their API. They're the food distributor. I'm going to use letFun here to create a function called order more buns that takes the count of buns and will add 20 to it. The body of order more just updates the inventory. Okay, so here I'm going to use the REPL to simulate a point of sale system purchase. So somebody walks in, they buy a coffee, cool. They buy another coffee, awesome. And the third person buys a coffee and a cinnamon bun. So he buys a coffee and a bun. It sees that there are less than 10 buns left. There are 9 buns left. And so it renders this button that allows the associate to order more buns. Order more, when the on click for this order more buns simply runs this order more side effect that we declared earlier. So let's order more buns. Now we have more buns. We can also check this with our REPL, even though I rendered it there. So how did we make this happen? So this is the aptly named component using make reaction. First, we have the count of buns, which is a deref of this make reaction here. And we have order more, which is really just a Boolean to render that button. We have some closure script. So When there are less than 10 buns, we're going to render this button on the on click. As discussed, we have this order more side effect. So reagents make reaction runs a function when it looks at a value and runs a function. This is very, very similar to reframes subscriptions. This is a very contrived example, and I tried my best to demonstrate that it doesn't need to do much, and you don't want to attach a side effect directly in the make reaction. You can't even do that anyway. Make reaction is just like, yo, watch this value over here. When this value changes, do this. Just do this thing. So look at it again, refresh the page. We bought a coffee, we bought a bun. The associate can order more buns. We order more buns. It's great. Bunalicious. Yes. You did it. You did it. Yay. Yay. You did it. You did it. You did it. What did you do? We reviewed plain old atoms. We learned why reagents' reactive atoms are better suited for a ClojureScript application when we're using user input to do side effecty type things. We also talked about another flavor of reactive atoms where you declare the state local to the component and only change it therein. We also talked about reagents are atoms make reaction, which is what reframe subscriptions use under the hood. So next video, we'll talk more about how reframe implements a lot of these things, and we'll have a good time. Hopefully you learned something. Bye. La la la, lost in lambdas, la la la, lost in lambda.